the ideology distribution and on voting behavior. And we test this using some novel data set that allow us to do it. And I will try to convince you that we find a very strong support. So I will try to convince you, I would really like you to leave this room thinking, well, overconfidence might be playing a role in politics. So what's the idea here? One of the most robust findings on how people form beliefs in the psychology literature and in the behavioral economics literature is that they are overconfident. Now, what does overconfident mean? I'll be much more precise later, but very roughly, it means that people tend to overestimate some ability of theirs. They think they're better than they actually are. Now, this can take many forms. You're better than you are, you're better than others, you think you know more. We'll discuss what we do, but the general feeling is that you overestimate yourself. And this has generated quite a large literature in economics and in finance, so there's a lot of work in finance to try to study how overconfidence affects portfolio selection, in economics how overconfidence affects entering in tournaments, and so on. And what we want to do in this paper is very, very simple. We want to take this idea to study political economy. In particular, what we will do is the following. We will develop a simple model of political beliefs with overconfidence. In particular, we're going to focus on what's called over-precision. That is, the tendency of people to assign too much confidence in their information. People think they know more than they actually do. In fact, we're going to microfound this into a notion of correlation and that. People neglect the correlation of the information they receive. And we're going to show that this has implication on ideology formation. And in particular, I'm going to try to show, and this is immediate, that overconfidence leads to ideological extremism. And then we're going to link it to voting, and we're going to show that overconfidence leads to voter turnout. More overconfident people will vote more. Now, in this theory part, which will be the first part of the talk, I should emphasize the model is very simple. Now, as a theorist, I should be a little bit ashamed of presenting a simple model. I mean, we all want, at least to have a couple of, invoke the Farkas lemma at least twice. But this is not going to happen. But in this specific case, I will try to convince you that simplicity here could be an advantage, in the sense that we are hoping to emphasize and to underline a special mechanism of how overconfidence works that we think it's very simple, but as far as we know, it's not been pointed out before, and we think can have applications in broader notions. After done the theory, we're going to test this prediction. So we have access to this novel data set that is beautiful in that it allows us to have information about subjects' ideology, subjects' voting behavior, but also subjects' overconfidence. All of this is in a representative sample, or almost represented subset of the US population. And then we can test our predictions, and we will find a very strong support. This is the basic idea. So what do we do? So the general idea, so first of all, I'm talking about overconfidence. So what is overconfidence? Now, overconfidence is, in fact, means everything and nothing in the sense that it means a bunch of things. And usually in psychology, there have been identified 3 types of overconfidence. And this distinction goes to Hill and Moore, which is, as far as I know, fairly widely accepted. First of all, people can do what's called overestimation, which is the fact that people tend to think they're better than they actually is. So, for example, I do an IQ test, and you ask me to expect how well I did, to predict how well I'm going to do, and I predict I'm going to do better than I do. The second time is called overplacement, which is that you ask me how well I think I'm going to do, and then you ask me how well I think others are going to do. And I'm going to say that I'm overconfident in the sense of overplacement if I think I will do better than others. The third type is this that called overprecision, which means I think I know more than I actually do. Typical example, you ask people, when was Shakespeare born? And people say 1255, which is really wrong. And then you ask them, how confident are you? I mean, do you think you know what you're talking about? Yeah, I really know. I mean, I was there. And it sounds ridiculous, but this is actually not unheard of. In fact,
yeah.
What's that?
There are gender differences.
There are gender, yes. So there are gender differences. In fact, one of the most typical findings. This is why a lot of the gender analysis and economics has been focused on this. There are phenomenal gender differences in overconfidence in general, in all three measures in particular. In fact, out of interest, in overplacement, gender difference is the biggest. Men think they're going to be the best, and women think they're going to be the worst. And this is being, there's quite a few papers that study women participation in the labor force and connecting this. Now, what we do in this paper is that we focus on this last feature, over precision. People thinking they know more than they do. We do it for two reasons. First of all, because we think it is a very natural interpretation in politics, and you'll see why, and you can probably imagine why. The second one is a bit of a deeper reason, which is that overconfidence is a very well-known phenomenon, but unfortunately it is also well-known to be a very unstable phenomenon. That is, when you run overestimation tasks, for example, you ask people different types of questions, and the same person might prove to be overconfident in some questions and underconfident in some others. So these are very unstable, except overprecision. Overprecision is considered the most stable feature within the broad class of overconfidence. So this is why we focus on it. And where are we going with this? Well, the basic idea is the following. So let me tell you a story. I'm going to give you a model that formalizes the story, but if you get the story, you get the whole shebang. The idea is that we get a lot of signals. So suppose we are trying to guess some important component of information that matters for our voting and for our ideology. And we get signals from the world around us. And the problem is that these signals could be correlated, because they could be geographically correlated or socially correlated. For example, think about this. It's October 2012. You need to decide whether you want to vote for Obama or for Romney, and you want to get some form of assessment of the state of the US economy. So you walk around and you're walking around the street and you see a lot of stores closing down, and you meet your brother for dinner and he says, yeah, I was just fired. And then your sister cannot find a job. And the situation around you is dramatic. You think, my God, the economy is doing horribly. But you might disregard the fact that all of this information comes from your city, and maybe you live in Detroit, and the fact that things go extremely poorly in Detroit doesn't mean they go extremely poorly in the country as a whole. What I mean to say is that very often you get multiple signals about some state of the world you might be interested in that are, though, correlated with each other. And because they're correlated, you should discount the amount of information they convey. However, people might underestimate the correlation. They might realize they're correlated but not fully account for it. This itself is a strong, this itself can be microfounded in the network literature. There's a very influential paper by DeMarzo and al., which is a beautiful paper, that studies how in networks people tend to underestimate correlation, and when information is propagated through social networks, this what happens. And there's a whole literature there, and it's the notion used in finance. But the fundamental idea here is that if you underestimate the correlation of the multiple signals, what do? You think you know more than you do. To see this, think about the extreme case. You think that each signal is independent, and yet each signal is perfectly correlated. Then what you're doing, you're overestimating your information. And therefore, you end up being exactly over-precise. You think you know more than you do. So let me just formalize what I just said. This is literally what I just said translated into math. There's a measure one of subjects. Measure one is relevant. There's a policy space of one-dimensional object. People have utility. They want to match the state of the world. In the paper, we also have preference biases. Nothing changes. We add a B here, which is an idiosyncratic thing. People have beliefs about the state of the world. We assume it's the same for everybody. It's a normal zero tau, where tau is the precision. And then each agent has an experience, which is a set of signals. Each person receives a bunch of signals from the world, which are, each of them, they're correct with the noise. The noise, each of the noise terms are independent, each of them is distributed as a normal 0, 1, but noises themselves are correlated with a correlation rho. Okay, nothing surprising here. Where's the twist? The twist is that noises are correlated, but people underestimate the correlation. People believe that instead noises are correlated with rho I, where rho I is bigger than 0, but is smaller than 1. And the I indicates that it might be heterogeneous across the population. That is, the various people might have different underestimation. Now, it's pretty obvious that after n signals, people will end up with a posterior. And importantly, let me use the following notation, which is horrible. After n signals, a citizen has a certain posterior with a certain precision. This precision is not the correct one in the sense that this precision might be different from the precision this person should have had if you knew the correct correlation between signals. And what we can look at is the difference between the precisions he has and the precision he should have. And we can call this difference the overconfidence. Right? This is literally the difference in the precision. If you're interested, you can think about, instead of taking the difference, you can take the ratio. Everything we say holds to these variations. And of course, the person is overconfident that the perceived precision and the precision they should have is positive if and only if they are underestimating the correlation. This is how we define overconfidence. The second thing we do is that we can also define the ideology of the person. We call the ideology the mean of the posterior belief. And we call ideological extremeness the distance from 0. First result. This is, if you will, is the most important result of the paper, at least in the theory part. And it's the following. Ideological extremeness is correlated with overconfidence. Why? It turns out it's really immediate. If you look at the following, so let me use pictures. This is a prior distribution of the agent. It's a normal distribution. It's supposed to be a normal distribution. Now let me look at information. So suppose that the agent received this information. In fact, the agent received multiple signals which are correlated. Let me just collapse them into one signal. We can just treat them as one signal. And suppose the information is here. Now, if this agent is not very confident in the quality of this information, that is, he knows that this information, these signals are correlated, what he's going to do is going to move his beliefs a little bit. Everything remains normal. So there is a movement, but he's not going to go very close to the information because he knows that the informational content is limited. By contrast, if you compare someone who's more overconfident, what this guy is going to say is that, this information is very good because it's a bunch of independent signals. So you know what? I'm going to follow it. This guy is going to move further away, and he's going to end up with a prior with a further away mean and a smaller variance. So what this is telling us is that people who are more overconfident should be moving further away from the prior. But what happens on the aggregate? Well, now I'm drawing, notice this is a different picture, now I'm drawing the average ideology for difference overconfidence. So this is no longer a belief, this is a distribution. Now, for it, and suppose that the true state of the world is exactly at 0. Okay, so your prior was right on spot. If the true state of the world is exactly at 0, what happens is that for no matter what your overconfidence is, your average, the average ideology of people should be at 0, because on average people get the right signal. But people who are more overconfident have a distribution with factor tails, because they move more. On average, these two groups get the same signals, but the blue guys move more, and thus they have factor tails. if you think it's trivial, it is trivial. You're right. Notice that, let me not insult our proof too much. It turns out it's really trivial in this case when x is equal to 0. What we show is that, well, when x is not equal to 0, meaning when the true state of the world is on the middle, is not at 0, the distribution of ideologies are not stacked on top of each other, and they tend to be in various places. And what we prove is that yet the correlation is still positive. So you can prove that it still holds. This is the first result. Second result. Suppose that the state x, the true state of the world, is not 0, but is positive. Then what should happen is that overconfidence and extremeness should be correlated more for people right of the median than for people left of the median ideology. What do I mean? This is much easier to see in a graph. Suppose that here what I'm doing is that I'm drawing the average ideology of people for different levels of overconfidence. Now suppose that x is here, 0 is here, and what's happening is the following, that on average people get signals that are around the truth, so around x. Now, people who are more overconfident, they're going to move closer to the truth because they trust the signals more. People who are not very confident, they're going to move very little because they don't trust the signals. So what happens is that more overconfident people should be to the right of less overconfident people, in a distributional sense. Now, let me then fix a median ideology. And let me look at the correlation between overconfidence and extremism left and right of the median. If you go right of the median, notice what's happening. When I go this way, as I proceed this way, the overconfidence of citizens is increasing. I'm going more extreme, and people become more overconfident. By contrast, when I go this way, the overconfidence of people is decreasing at first because I'm hitting the bulk of the less overconfident citizens. And then down the road, it's going to be increasing more. And what you can prove is that, in fact, the correlation should be higher here than it is here. Next, multiple signals. What happens when people get more signals? This is something that, well, we didn't foresee. Suppose that you allow people to get more signals. The first thing you get is that people who get more signals are more overconfident. This is obvious because, the more signals you get, the more mistakes you tend to make, right? Because you're underestimating the correlation. Yet, the interesting thing is that how does it work for learning? In particular, if you get more signals, do you know more or less? And depending on the parameter, there are parameter values for which ideological extremeness should be increasing with the number of signals. What I'm telling you is the following. I'm giving people more information. These people are underestimating the correlation. And what happens is that instead of everybody collapsing to the truth, as it happens on the base rule, people are moving away from each other. Their extremeness increases. So with more information, you have literally the opposite of base rules. Under Bayesian is we collapse, under correlation neglect, under our model, we expand. Doesn't always happen. When does it happen? It happens when the true correlation, essentially when the difference between the true correlation and the perceived correlation is big enough. If you're interested, this is essentially whenever the true correlation is above 1/4, this is virtually always true. So it holds for a very, very large number of parameters. Interestingly, this means that the subject with more signal could become more extremes. So for example, in passing, think about the availability of more media and the internet. This is giving us more signals. These signals are correlated. If we fail to perceive the correlation, this could generate polarization. This is a cheap story, but it's a story. Now, if you want to connect it to some data, something we're going to argue is the following. It's pretty, we think that older people receive more signals.
But they forget.
Actually, this will show up in the data. The fact that they will forget. No, but this we believe on. I mean, there's a sense in which older people have received more signals about efficiencies of policies and so on. And so this is telling you that older citizens should be more confident, and under certain parameters, they might be all over the place. Last theory bit, turnout. We model turnout in the following sense. Two parties and subjects vote for the parties they like best, but they vote only if there is a party that gives them, to which they assign a high enough chance of being the best for them. So they vote if they really don't know who's the best party for them, meaning if they don't assign a high enough chance to either party being the correct one, they just stay home. Otherwise, they go and vote, and they vote for the favorite party. And this is connected to expressive voting, of course, and you can derive exactly this form using one of the Matsusaka, model by Matsusaka, by Pigan and Merlo. This is a model that connects voting with choice avoidance or regret. And in the paper, we go at length to discussing these things. And what happens is that if you make this assumption, what you get is that more overconfident people should be more likely to vote, and that's probably intuitive. But interestingly, and this would be a very demanding proposition for the data, they should be more likely to vote, even conditional on their ideology. Because even when I fix ideology, more overconfident people at that ideology, they should have a narrower belief, and therefore the probability they assign to the fact that they know is higher. So these people should vote more, even conditional on ideology. And vice versa, if you fix overconfidence, extremeness and voting should be correct. Okay, empirical analysis. What's our data set? We use the 2010 Cooperative Congressional Election Survey, which is an almost nationwide survey, and in particular we are using the data set that Steve and Eric have collected for the 2010 work, which is about 3,000 respondents. And the beauty of this data set was that what they do is that they ask subjects what they think the unemployment rate is right now, the inflation rate is right now, and the unemployment and the inflation rate are going to be 1 year from now. And then they ask them, how confident are you in a 6-point scale? That is, they get a measure of confidence. Now we take this, and from this we want to extract overconfidence. How do we do this? We look at their answers on their confidence, and this gives us confidence. But the problem is that we cannot use confidence to get overconfidence, because there might be people who know better, but who tell you that they are more confident because they know better. I mean, Bernanke likely knows the inflation rate, and he's probably overconfident, but I cannot get it from that answer because he knows. So how do I do it? Well, the advantage here is that we know whether they were right or wrong. So fundamentally, if someone tells us the inflation rate is 49%, and I'm sure of it, I want to call this guy overconfident. If someone tells me the inflation rate is 2.35%, suppose it's the true value, and I'm sure of it, I don't want to say he's overconfident. I'm guessing probably this guy knows what he's talking about. So in practice, how we do it is that we call overconfidence as the residual of a regression in which we regress confidence on a fourth-order polynomial of the accuracy of the answer. So the idea is that confidence is knowledge plus overconfidence. To take knowledge out, we use a regression. And we allow a fourth-order polynomial. Now, I don't have time to go into detail, but the fact that we use a fourth-order polynomial goes against us. If we use lower polynomials, we would, in some sense, help us in our case quite a lot. And if you're interested, our analysis work on if you focus on your confidence. That is, you forget about correcting for knowledge. Then we have 4 measures of confidence. We use the first principal component of these 4 measures. We get 1 measure of overconfidence, and this is what we do. Now, a couple of caveats. There's a few things here you might not like. The first one is that these are constructed using measures that pertain to unemployment and inflation. Now, unemployment and inflation are political measures. For example, if you go to a Tea Party rally, you hear a lot of people talking about inflation and unemployment. Inflation, no, but unemployment, yes. So you might be worried that, in fact, here our measures of overconfidence is capturing something political already. The second thing you might be worried about is the fact that we talk about future estimates, and it might pertain to beliefs about the future, and who knows how this will behave. Now, we have two answers to this. The first one is that everything we do holds using any individual as these answers. That is, we can just focus on each of them, everything works. Most importantly, what we did is that in 2011, we ran, in the 2011 version of the CCES, we ran 1,000, for 1,000 people, we added questions in which not only we were asking exactly what we're asking here, but we also asked questions to measure overconfidence using trivia questions, such as, when was the telephone invented? When was Shakespeare born? What is the population of Spain? And what percentage of the US population lives in California? We can redo all of our analysis using answers to trivia questions, and everything works. If anything, it works better. What I mean to say is that you might be worried that you're getting the causality wrong, and that ideological position might affect the beliefs about unemployment. And this could be a worry. But because we can do everything using the year in which Shakespeare was born, I hope you agree with me that in Tea Party rallies they don't talk about when Shakespeare was born and when was the phone invented. So we don't think we have, at least this issue of reverse causality, we don't think we have. All right, so this is what we do for overconfidence. How do we get extremism? We use item response theory. We build an ideology measure using item response questions such as pro against abortion and so on. In fact, the nice thing here is that we don't do it. Tausanovic and Warsaw have a paper that computes this measure of scaled ideology for this data set, and they shared it with us. So we didn't have to, mess with we had no say in how to construct it. Everything I'm going to say holds with self-reported ideology with a bunch of possible ways. And then we construct ideological extremism folding around 0, and we divide everything for the standard errors, for the standard deviation to make coefficients inverted. Results. I've argued our main result is that extremeness is correlated with overconfidence. What do we get? This is really strongly true. What do I mean by really strongly true? Look at the division. The t-statistic here is well above 10. This, we think, is a very strong result. This is without controls. Let's throw controls in. Put income, education. You can use union membership, religion, affiliation, whether you go to church, add the gender, or you can add all controls. Which controls did we add? We didn't know, we throw everything in. We added 165 controls. Kitchen sink. Even adding 165 control, this is significant with a t-statistics which is 8 plus. I mean, this is significant at the 0 point, a bunch of zeros. So, I would like to argue, what this table shows is that overconfidence has a strongly statistically significant effect on ideological extremism. Now, I told you this is statistically significant, but I haven't told you it's important. Meaning, it can be a marginal effect which is just very significant. How do we understand whether it is important? Well, here's how we're going to do it. We're going to compare it with other stuff we think is important. In particular, you can look at one standard deviation change in some specific dimension is associated with a percentage of a standard deviation change in extremeness. And we have things like income, education, race, church attendance, and gender. And what we find is that overconfidence is in the upper part of these guys. So if you think that going to church matters in determining your ideology, the ideological extremism, or your union membership, which is not here, but it's very similar to church, matters in determining your extremism, you should think that overconfidence does as well. If anything, of these measures, overconfidence is amongst the strongest one, together with income and education. So what we're trying to convince you is that it looks like overconfidence is playing an important role, at least our data suggests that overconfidence is playing an important role in ideological extremism, if you believe our causality, of course. Next, do you remember we were saying that if X is positive, things should be more stronger to the right than to the left? They are ridiculously stronger to the right than to the left. Using the scaled ideology, to the left is not there, to the right is there. The difference is ridiculously significant. This is with all controls. This number is much higher than it was before. So we're getting, in our data set, things are much stronger to the right, to the left of the median ideology. Notice that this is consistent with the theory. I mean, the theory is telling you exactly that this is going on because you're getting centrist because of the pool of the centrists. Second result, remember we said that with age people could get more overconfident? What we find, and this is very easy to see from the graph, is the following. As people get older, they are A, much more overconfident until the age of 80. B, B, much more extreme. Now you may think, yeah, it's because people older people are more extreme because they are more right-wing. And it's true, they are a little bit more right-wing. But the important observation is that older people are more all over the place. Standard deviation increases with age, which is exactly what the model predicts. I mean, all of these are predicted by the model. And it's the opposite of what Bayesian would say. Quickly, turnout. Overconfident people should vote more. Even conditional on ideology, strongly there. Notice these are the data on turnout. These are verified turnout data. So that's the beauty of this data set. So we can, there is no cheap talk there. If you compute the effect on turnout of overconfidence directly, it's strongly significant. Interestingly, it's strongly significant even when you control for extremeness. So overconfidence adds on to extremeness in the probability of voting. I've told you that overconfidence is an important thing for it matters. This is just statistical. What is the effect size? What we find is that overconfidence has an additional impact, which is about half of the impact of the ideological extremeness. So if you think that extremists vote more, overconfidence adds about half additional impact on top of that. So we think it's a strong effect.